Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discussing about another method, Euler's method. Okay, so let's start the session with this important method. First of all, see the statement of this Euler's method. Describe briefly the Euler's method for solving dy by dx is equal to f of x comma y with the initial condition y of x naught is equal to y naught. Okay, in the statement only they ask that briefly. Okay, so discuss briefly the Euler's method. Okay, so this method does not contain much more proof. Okay, so we can prove this method as much as easy possible. Okay, so therefore describe briefly the Euler's method for solving dy by dx is equal to f of x comma y. That is a, you know very well, the first order differential equation, or else also we can call it as an initial value problem with the given initial condition y of x naught is equal to y naught. Okay, so now start the solution of this method directly. Solution, the Euler's method. So far we discussed that Taylor series. Okay, so far we discussed that the Taylor series method and the Picard's method. These two methods yield the solution of a differential equation in the form of power series. Okay, so why I am adding this note on this point is, so far we discussed that the Taylor series method, that is the first method in this unit, and after that Picard's method. Okay, these two methods based on the power series of a differential equation. Whenever you solve a differential equation by using these two methods, the solution, the exact solution y of x is in the power series in the variable of small x. Okay, now we will discuss the Euler's method. Now we are discussing the another method, that is third method out of four methods. So this Euler method is the third method. The Euler's method which give the solution of a differential equation in the form of a set of tabulated values at the introduction class. Okay, so in the beginning of this unit only we discussed that Taylor series method and Picard's methods give based on the power series solution, and Euler's method and Euler's modified method and Runge-Kutta method. Okay, on based on the Euler's method only there is some modification for this method, Euler's modified method, and next method is Runge-Kutta method. These two methods based on the a set of tabulated function. Okay, so that is only they are mentioning here in that point. Okay, now given differential equation is, so okay, we are starting the derivation for the Euler's method. Given differential equation is dy by dx is equal to, simply we can write that value as y dash is equal to f of x comma y, f of x comma y with the initial condition y of x naught is equal to y naught, with the initial condition y of x naught is equal to y naught. Up to here you know very well, for the any Taylor series method, Picard's method, Euler's method, and the next upcoming methods also the same. This step is the same. మనకి ఏదైతే సినిమా స్టార్ట్ అయ్యేటప్పుడు సెన్సార్ సర్టిఫికేట్ వాళ్ళు కొన్ని యాడ్స్ చేస్తారు కదా, సో ఆ యాడ్స్ ఎలాగైతే అన్నిటికీ సేమ్ ఉంటాయో, సేమ్ ఫర్ దీస్ మెథడ్స్ కూడా this process is the same up to here. Now suppose that we wish to solve equation number 1 for the values of y. Okay, so now we wish to solve that equation number 1 for the values of y at small x. Here the function is y of x. Okay, so we have to solve this value of this y at the variable small x. ekkada x values kuda manaki ekkada unnayante x is equal to x suffix r, x is equal to x suffix r. Okay, small x is equal to x suffix r. You know very well the formula x suffix r is equal to x naught plus r into h, x naught plus r into h, where r is equal to 1 2 3 up to so on. Okay, so integrating equation number 1 at x naught less than x less than or equal to x1. So now in the Picard's method also, second method Picard's method also, for the given initial value problem we integrated. Okay, so to get the exact solution of the given equation we integrated that in that method. Same in the Euler's method also, given equation number 1 we are going to integrating, but this in this method the procedure is different. So you can see here we are differentiating given equation number 1 with respect to the interval, okay, x naught x1. Okay, so where small x belongs to closed interval x naught comma x1. Okay, in that interval only we are going to integrating that equation. Therefore integration over x naught to x1 y dash dx. Okay, y dash dx is equal to Okay, so therefore integration over x naught to x1 f of x comma y dx, f of x comma y dx. So and LHS, if you apply the integration, okay, so integration derivation will get cancelled, y into upper limit lower limit, okay, x1 x0 is equal to integration over x0 to x1 f of x comma y dx. That is the RHS is same. Now apply the values upper limit, okay, y of x1 minus lower limit y of x0 is equal to integration over x0 to x1 f of x comma y dx is same in the RHS. Now what is that y of x1? y1. Okay, from the initial condition y of x0 you have y0, that is equal to integration over x0 to x1 f of x comma y dx. Now send this negative value minus y0 to RHS, so therefore y1 is equal to, you will get y0 plus integration over x0 to x1 f of x comma y dx. That is taken as equation number 2. Equation number 1 is the given initial value problem. Equation number 2 is the our first value, okay, first integration value of the function y at x is equal to x0 comma x1. Let here, after getting equation number 2, you can observe this function value f of x comma y is there. Now let f of x comma y is equal to, I am writing as f of x0 comma y0. ఏదైనా ఫంక్షన్ లో కాన్స్టెంట్ వాల్యూస్ x0 comma y0 values substitute చేస్తే, so you will get again constant only. Here f of x comma y is the function in terms of two variables x and y. In place of them, if you substitute x0 and y0 in closed interval x0 comma x1, then you will get a constant only. That entire function will become constant. Then we can write y1 is equal to, from the equation number 2. Okay, we can write from equation number 2. From equation number 2, y1 is equal to, y0 will be as it is, we are not disturbing y0 value, plus next to f of x comma y value will become f of x0 comma y0, f of x0 comma y0, then it will become constant. Okay, for the constant we cannot apply the integration. Okay, next term we can apply the integration, that is f of x comma x0 comma y0 will become constant. So then you will apply the integration here, integration over x0 to x1, okay, f of x0 comma y0 dx will come. Okay, so f of x0 comma y0 is a constant, you can write f of x0 comma y0 outside of the integral, integration x0 to x1 dx. Okay, so therefore integration f of x0 comma y0 into, here 1 into dx means x only. Okay, integration of 1 into dx means x, you can apply that upper bound x0, lower bound x0 to upper bound x1. So therefore f of x0 constant value, f of x0 comma y0 will be same as it is. Now apply the upper limit x1 minus lower limit for small x value, x1 minus x0. Okay, x1 minus x0, what you will get the value, small h, x0 comma y0 is equal to x1 minus x0, x1 means small h. That is only I am writing here h into f of x0 comma y0. Here you know very well this formula, x suffix r is equal to x0 plus rh. For example, if you substitute r is equal to 1, x1 is equal to x0 plus h. So therefore x1 minus x0 is equal to, you will get small h. Okay, x1 minus x0 is equal to small h. So here also that integration value we are getting x1 minus x0, in the place of x1 minus x0, by using the given interval value we can write small h. Okay, so that's why directly we can write from equation number 2, whenever you substitute that Ingrand value f of x comma y value is equal to f of x0 comma y0, that function will become constant. If you apply that integration for the constant function, you will get subtraction of the upper limit minus lower limit, that value you will get the step size, that is small h. This is the first integration. Similarly, for the range of x is equal to x1 comma x2, next to small x value variable range మనం ఏమని తీసుకుంటామంటే x1 comma x2. ఫస్ట్ ఏం తీసుకున్నాం, x0 comma x1 అని తీసుకున్నాం ఫస్ట్. Now we are taking that range small x belongs to x1 comma x2. Then from equation number 2 we have y2. Okay, y1 will become y2 in LHS and y0 will become y1 in RHS plus x1. Integrals also will change, integration over x1 to x2 f of x comma y dx. From equation number 2 directly we are writing. Here also you have f of x comma y dx value, same you can apply the process. After you getting first integration, you will get that function value. Okay, so that function value f of x comma y you can replace with f of x1 comma y1, f of x1 comma y1 in the interval small x belongs to closed interval x1 comma x2, then this function is also, you will get some value. For that value, if you apply the integration, y2 is equal to y1 plus h into f of x1 comma y1. Okay, for that equation and for the y1 value and y2 value, you will get the equations. If you proceed in this format, proceeding in this way, we obtain the general formula. What is that general formula? Nth approximation, that is n plus 1 approximation, y suffix n plus 1. Y suffix n plus 1 is equal to y suffix n plus h into f of x suffix n comma y suffix n. So okay, if you proceed in this format, you will get that the n plus 1th approximation for the Euler's formula, that is given as in this format, where n is equal to 0, 1, 2, 3 up to so on. Okay, and here the step size small h is calculated by taking the difference between the two successive values of small x. Here the step function small h we can calculate it. Why? Because in Euler method small h plays key role. Okay, so that is the drawback of this method only. Okay, so small h plays the key role and small h is the drawback of this method. Okay, so that's why we are discussing with the modification of the Euler's method. So here small h value is calculated by taking the difference between two successive values of small x. Okay, now for initial value of x naught, we can write x1 is equal to initial value of x naught. X naught they will give in the problem. Why? Because in the initial condition y of x naught is equal to y naught. Their x naught value they will give in the problem, and now initial value x1 you can take f of x naught plus h. For that x naught, if you add h value, okay, by adding those two values you will get one value. That value if you substitute in the function, you will get x1 value. Next x2, f of x naught plus 2 into h, then you will get x2 value. What are the use of this x1 and x2? You can substitute in the function. Okay, so here you can substitute in place of x suffix n and y suffix n. So therefore based on the x1 value you will get y1, based on the x2 value you will get y2, then you can substitute the function values. Now by substituting the corresponding values of small x in the above formula, okay, in this formula, so the values of small y can be calculated. Okay, by Euler's method we can calculate the small y value in this format. Okay, so this is the general procedure for the Euler's method. Now here we have one note point. You can see that the Euler's method process is very slow to obtain a required accuracy. Okay, so Euler's method process is very slow to obtain a required accuracy, and by using this method to find any value of the initial value problem, so it will take some time. The process is very slow. Okay, and we need to take a smaller value for small h, and to avoid that slowness we have to take that h value will be as much as less. Okay, so we have to take the smaller value of small h. That means this small h plays key role in this method, and that small h is the drawback of this method. Not we can call it as a drawback, but we have to consider small h as much as less value. Okay, so due to this slow narration, okay, due to this slow process, so we have one remark regarding this method. That remark is due to restriction on small h value. అంటే చెప్పాం కదా small h అనేది తక్కువ ఉండాలి, అది ఎంత తక్కువ ఉంటే ప్రాబ్లం మనకు అంత స్పీడ్ అవుతుందని. Due to restriction on small h value, this method is unsuitable, okay, unsuitable for practical use, and modification required. Okay, modification required for this method. That modification is known as modified Euler method. Okay, this modified Euler method gives more accurate results, okay, than Euler's method. This modified Euler's method gives the more accurate results than Euler's modified method. Okay, so we discussed the general derivation of the Euler's method and what is the drawback of Euler's method. Okay, so it has slow process, and we have to consider a small h value as small. Okay, due to the restriction based on the small h value, for this Euler's method we have an updation. Not only updation, we have some modification. That modification, based on that modification, we have another method, modified Euler method. In that modified Euler method, we can get the more accurate values if you compare with the Euler method. Okay, so ఈ మెథడ్ లో జనరల్ ప్రొసీజర్ డిరైవ్ చేసాము. ఈ మెథడ్ కున్న డ్రాబ్యాక్, ఈ మెథడ్ కున్న నెగటివ్ పాయింట్ ఏంటో డిస్కస్ చేసాము, అండ్ ఈ మెథడ్ ని కాకుండా మాడిఫైడ్ యూలర్ మెథడ్ ని ఎందుకు రిఫర్ చేయాలనే దాని కూడా రీజన్ కూడా డిస్కస్ చేసాం. ఓకే, సో దిస్ ఇస్ ద టోటల్ ఎక్స్ప్లెనేషన్ ఆఫ్ దిస్ మెథడ్. అండ్ టోటల్ డెరివేషన్. ఎందుకంటే ఎగ్జామినేషన్ లో లాస్ట్ ఇయర్ క్వశ్చన్ పేపర్ లో డిరైవ్ ద పికార్డ్స్ మెథడ్ ఫర్ ద ఇనిషియల్ వాల్యూ ప్రాబ్లమ్స్ అని అడిగాడు. పికార్డ్స్ మెథడ్ యొక్క డెరివేషన్ అడిగాడు అండ్ టేలర్ సిరీస్ మీద ప్రాబ్లం అడిగాడు. సో కాబట్టి నెక్స్ట్ అప్కమింగ్ ఎగ్జామ్స్ కూడా ఈ అవుట్ ఆఫ్ 4 మెథడ్స్ ఇంక్లూడింగ్ యూలర్స్ మాడిఫైడ్ మెథడ్ అనుకుంటే మీకు 5 మెథడ్స్ అవుతాయి. అవుట్ ఆఫ్ దిస్ 5 మెథడ్స్ డెఫినెట్లీ యూ విల్ గెట్ అట్లీస్ట్ 2 మెథడ్స్ డెరివేషన్ అడుగుతాడు ఎగ్జామినేషన్ లో. If they miss the derivation, they will ask the process how we can find the solution for the given initial value problem by using the Euler's method. Explain the process అంటాడు. ఆ ప్రాసెస్ కూడా ఎలా ఎక్స్ప్లెయిన్ చేస్తామంటే ఇదే మెథడ్. ఇప్పుడు మనం ఏదైతే స్టెప్ బై స్టెప్ తీసుకుంటాం కదా, ఫంక్షన్ తీసుకుంటాం, దాన్ని ఇంటిగ్రేషన్ చేస్తాము. ఇంటిగ్రేషన్ చేసినాక ఒక ఈక్వేషన్ వస్తుంది. ఆ ఎఫ్ ఆఫ్ ఎక్స్ కామా వై ప్లేస్ లో ఎఫ్ ఆఫ్ ఎక్స్ నాట్ కామా వై నాట్ ని సబ్స్టిట్యూట్ చేస్తాం. ఇదే ప్రాసెస్ ని మీరు అక్కడ స్టెప్ బై స్టెప్ క్లియర్ గా రాసి ఆ n+1 డెరివేటివ్ ఫార్ములా రాసి లాస్ట్ కి ఒక చిన్న రీమార్క్ అని పెట్టేసి, ఈ మెథడ్ లో స్లో ప్రాసెస్ ఉంటుంది, స్మాల్ హెచ్ వాల్యూ తక్కువ తీసుకోవాలి కాబట్టి డ్యూ టు రిస్ట్రిక్షన్ వల్ల వీ కెన్ టేక్ దట్ మోడిఫికేషన్ అని చిన్న లాస్ట్ డైలాగ్ మనదైతే వచ్చే కిక్కే వేరే పంట అని చెప్తాం కదా. సో అలాంటి ఒక చిన్న మంచి కంక్లూషన్ ఇచ్చారనుకోండి, డెఫినెట్లీ దే విల్ ఇంప్రెస్. ఎవరైతే మీ ఆన్సర్ షీట్ ని కరెక్షన్ చేస్తారో ఖచ్చితంగా ఇంప్రెస్ అవుతారు అనమాట. ఓకే, సో ఓన్లీ ద సబ్జెక్ట్ యూ విల్ గెట్ సెంట్ మార్క్స్. ఓకే, యూ విల్ గెట్ అవుట్ ఆఫ్ 100 you will get 100 marks. The only subject is mathematics only. అక్కడ ఉన్న మీకు పాసిబిలిటీని యూజ్ చేసుకోండి. ఓకే, సో this is the total explanation. You understood this problem very well. In the next lecture we are coming with the Euler's modified method and problems based on it. Okay, so make a perfect practice, prepare well. Until bye, thank you.